Okay, in this example, let's find out the definition of a complex number. Then what is a complex number? Okay, first of all, we can write the complex number in standard form like this. A plus bi. Okay, and in this case, a and b are real numbers. What happens if this b is 0? Okay, b is 0, then bi will be 0. So we have only a, which is just a real number. So if b is 0, then it's just a real number, a. But if b is not a 0, then what happens? We have I form, a plus like 2i, 3i, 4i, something like this. So whenever you have a plus bi with the I form, then this is a complex number. Or we can say also it is an imaginary number. So the complex number is composed of two parts. One is real number part. Okay, this is the real number part. And the other one is imaginary number part. Alright, then how do we determine whether two complex numbers are equivalent? Okay, so we may say two complex numbers are equivalent if the real number parts are same. So this a part, the real number a, and this real number are the same, and also the imaginary number parts, so b and d, are same. Then we call these two complex numbers equivalent. Okay, so the real number parts a and c should be equal, and b and d should be equal. Then these two complex numbers are equivalent. Okay, so let's check. Okay, now let's check if two complex numbers are equal. Then how do you determine if the complex numbers are equal? Alright, so we have to check the real number part. If a and c, the real numbers, are equal, and the imaginary number parts, b and d, are equal. So b and d are equal, and the real number parts a and c are equal, then two complex numbers are equal. So let's rewrite the first complex number in I form, because one of them is square root of negative. Okay, square root of 9 is 3 squared, which will be 3, and square root of negative 48. Okay, negative 48, let's write 48 as a product of some squares. So 48 is 2 times, okay, we can start with 2 easily. So 2 times 24. 24 is 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. So this can be, 48 can be a product of 2 squares. 2 squared times 2 squared times 3. So 2 squared times 2 squared times 3. And then negative, square root of negative 1 becomes an I. Then simplify this one. So 3 squared is 3 plus 2 squared times 2 squared. Since the powers are equal to the square, the index, this base 2 and base 2 get out from the square root symbol. So 2 times 2 is 4. Square root of 3. Okay, this is the simplified form written in I form. So let's check let's compare each real number part and imaginary number part. So is it equal to the right hand side? 3 minus 4 square root of 3i. Let's check if they are equal. Okay, the imaginary number parts 3 and 3 are equal. Okay, good. How about, the real number parts 3 and 3 are equal. How about the imaginary number parts? Okay, the left hand side is 4 square root of 3. The right hand side is negative 4 square root of 3. They are not equal, different. So we can conclude that two complex numbers are different, not equal. Okay.